Believe it or not, this is a diamond. And the reason you can't see it is because it's covered with the darkest color on Earth. In fact, this material is so dark that it captures at least 99.995% of incoming visible light. But why is it covering a $2 million diamond? And how was it made in the first place? You may remember this color, Vantablack. It was unveiled in 2014, and media outlets called it the darkest color in the world. But this color here, it's not Vantablack. It's even blacker. And that's thanks to an unprecedented collaboration between science and art. It all traces back to this artist, Demoot Streeb. In 2014, she set out on a mission to find the blackest black. Her goal was to make a diamond disappear.
This project explores how value is attached to concepts and objects in reference to luxury and art and society.
Meanwhile, a scientist named Brian Wardle was on a totally different mission. He was working with a material called carbon nanotubes, the same stuff used to make Vantablack, though he was using them to boost the thermal and electrical properties of materials like aluminum. But little did Wardle know, he was producing something even darker than Vantablack.
Brian was looking into the optical properties of CNTs only because of the art project, and so it kind of caused, really from this art project, the research to find the blackest black.
The new material, which Wardle has yet to name, is 10 times blacker than any other color ever reported. And that likely has to do with the structure of those nanotubes themselves. In this case, Wardle and his team grew them on top of aluminum. Yeah, they may not be alive, but you can actually grow carbon nanotubes. First, you cover a material with microscopic metal particles. Then, you bake it at high temperatures in the presence of a hydrocarbon gas. And that's basically it. Carbon nanotubes will sprout out of those metallic particles like plants from seeds.
You do it in the way we've done it here, you get the recipe right, you can create forests. So these are very, very long, aspect ratios of like 1,000,000, right? The length of the tube is like 1,000,000 relative to the diameter. And that grows into what's called a forest.
That nanotube forest is the key to creating this black color. When particles of light called photons enter it, nearly all of them get trapped and then dissipate as heat. That's why when you look at this black, you see, well, absolutely nothing. No shadows, no ridges, just black. And that made it perfect for Streeb's diamond vanishing project. In fact, Wardle's team followed the exact same procedure to grow those nanotubes directly onto a diamond. And that's pretty wild when you consider this.
Both is made of carbon. It's the same element, just the different atomic lattice structure makes them so extreme opposite in their phenomenology, in their appearance.
And as it turns out, this material isn't just useful for multi-million-dollar art projects. Scientists can also use it to reduce the glare in optical sensors, such as for telescopes that explore distant objects in space.
If you have a material that can absorb the stray starlight, then you can look further or look in more detail at objects such as exoplanets.
But here's the thing. As cool as this color is, it likely won't be the darkest for long. Because even an absorption rate this high still leaves some room for improvement. So keep your eyes peeled for the next color that you can't see.